All right, guys. Matt 6620 here. Let me bring you up on. I've got Blackboard up here, and I want to show you something. There's a data set BSRI, and I uploaded a video on it illustrating factor analysis and principal component analysis, and it was okay. It was probably one of my better videos because it illustrated more appropriately, real life stuff that we run into with statistics. Let me explain that a little bit more to you. What I mean by that. First of all, this whole quantitative measures 1 and 2 course. What was the intent? And I say what was the intent because technically after this video, we are done with the quantitative methods and we're going to move into the test theory component. Now the test theory part is clearly, I don't know clearly, but it's related to this factor analysis, principal component analysis in ways that I'll try to teach you in the upcoming weeks. But anyway, backing up a little bit, so far, we started out with a simple t-test, then we went into 2 sample t-tests, pooled and unpooled. We went into ANOVA. We got into factorial designs, Mancova. And now that all the smoke clears, I want to repeat, what was my intent of all this? Well, my intent was not to turn you into an expert on any of those. It'd be great if somewhere along the way that actually happened, but again, that wasn't my goal. That wasn't my expectation. My expectation with this quantitative methods was just to introduce you to lots of different types of things that we encounter in education research. Now, for example, if you run into a situation where a Mancova design is appropriate, should you just know right off the bat how to run one of those, how to test the assumptions? Absolutely not. Guys, I don't even know how to do that. I understand Mancova, I understand the assumptions. I can, tell you those things on a dime, but I got to look it up. I got to look up the R code. I got to look up, what, how to do stuff on R. I don't walk around with all this stuff remembered. I have to look it up, and I have a notebook that I keep the stuff in. Secondly, testing the assumptions and things. But anyway, I guess long story short, the point I'm trying to make here is I can't prepare you for everything. When we get into to real life data, you run into things that aren't necessarily presented in these ideal data sets that we get out of these textbooks. So, and there's no way that I can, for example, running a factor analysis. I'm working with 2 doctoral candidates right now, and they're both having problems with some results, some reliability, some Cronbach alpha results. They're both having some difficulties with results from principal component analysis. There's nothing that I could have given them in a class that would have prepared them for that. It's just the fact that they know something about factor analysis. They understand a little bit about principal component analysis. They've seen them run. They see, overall what we're trying to accomplish here. But there's no way I can prepare you for everything, just like they weren't prepared. But in terms of more specifically the master's thesis project, I'm going to be there right with you through 6996, 6997, 6998. I'll be there right there with you. So when we encounter those things, I'll help you. Or well, you may encounter some things that I don't know how to work, and then in situations like that, we'll figure it out together. So anyway, I want to end up this PCA factor analysis with one final illustration. It's one of my favorites. I got this this data set directly from Andy Field's book. This guy just cracks me up in terms of teaching statistics. I think he's one of the more clever. If you've got if you're a little wheezy, you may not want to listen to his videos because he gets pretty crazy in some of them. But he's doing a great job in making connections between using statistics and using R and SPSS for the data analysis. The statistics part, I'll tell you right now, after it's all said and done, the statistics part's the easy part. What drove me crazy and made me, or gave me the most frustrations and the most challenges was making the connection between the statistical techniques, such as Mancova, for example, and how we do that on R. And since most of you, well, all of you will use R for your data analysis, that's why we decided to do it this way. So guys, anyway, Andy Field came up with this hypothetical data set. Actually, I think he did give this to about 20, almost 3,000 students, and he shared the results, and that's what I'm going to do with you, is run through the survey responses that he received. And if you look down through here, some of this may be kind of recently, it may seem slightly appropriate, unfortunately. Statistics makes me cry. My friends will think I'm stupid for not being able to cope with R. Standard deviations excite me. I dream that Pearson is attacking me with correlation coefficients. Well, guys, when you go down through these, you can, and this is posted on Blackboard, so feel free to look at those. The thing that I noticed right off the bat here is, hold on, my dog wants out. Imagine that. Darby, your timing is impeccable. All right, sorry about that. Anyway, when I look down through these 23 items that they gave to, again, almost 3,000 students, everything I read down here, and again, let me back up a little bit. These responses are on a Likert scale, so strongly disagree, and so on and so forth. But notice that statistics makes me cry. Strongly agree, to me, indicates a frustration, a strong frustration level. My friends will think I'm stupid for not being able to cope. Strongly agree, strongly frustrating. Let's go down to number 6. I have little experience of computers. Strongly agree, possibly a frustration level. All computers hate me. Strongly agree, frustration level. However, when I come back to number 3, standard deviations excite me. Strongly agree doesn't indicate a frustration. Strongly disagree would. So one of the first things you've got to do when you get a questionnaire or a survey, which believe it or not, many of you will do in your master's thesis. I'll require some of that stuff, just depending on what you're trying to look at. But what you want to do, and one thing I don't like about this survey is I look down through these questions. All of the, I think 20 is funny. I can't sleep for the thoughts of eigenvectors. Let me know if eigenvectors are driving you crazy, and I won't do anything different. I wake up under my duvet thinking I'm trapped under a normal distribution. Well, again, strongly agree would be frustration. So what I think he should have done out of the 23 responses, I think he should have posed these questions, about half of them, let's say maybe 10 and 13, but half of them where they are posed where strongly agree indicates less frustration, and then another maybe half of them, so to speak, strongly agree indicates more frustration. That way you don't get someone that's just, it's just really frustrated and just starts checking off stuff, just kind of gets in a pattern. You kind of mix up the way that they're actually having to think about the responses that they provide. So anyway, gang, what we'll need to do here on number 3, and I'll show you the data set in just a second, we will need to change those answers, make our 1s equal to 5 and our 2s equal to 4, and our 3s, of course, will remain the same. So, gang, let me show you the data set. It's really cool. Okay, it's sort of cool. Okay, maybe it's not cool at all. But I thought I already had this up. No, I didn't have it up. So let's go into 200 because I like to be able to see these things. I just I like things to be centered. So what I want to do here is I will want to recode my fives as ones and my ones as fives and twos as fours and fours as twos. And threes will be just fine, only for question 3. So what I'll do is I'll need to sort that. So for Mac, I need to go up to Data and come over here to Sort. And it'll ask you, do you want to expand the selection? Well, obviously, you just don't want to sort this this column. You want to expand the entire selection because, for example, this person right here on number 2 line, this is the first subject, and they have response of 4 on question 1, 5 on So we want these responses to remain consistent with that particular subject. So we're going to expand the selection. And I know that probably goes without saying, but give me a break, okay? So let's go in here and let's change all these to fives. While I'm doing this, I'll tell you that I'm on 2 dissertation committees right now and 3 master's theses. And the dissertation committees, the things that are driving my students crazy are exactly what you guys are going to be learning over the next few weeks. Reliability, validity, Cronbach's alpha, internal consistency. So the nature of the course really changes here over the next few days, well, starting next week. And this may take a while because this is an enormous data set. And this runs extremely slow. Oh wow, I'm going to be here forever. Wow, we should have some music. I would stop and redo the video, but I don't want to. I could have done an if-then or a replace if that would have probably been best. But then I would have had to figure that out, so... Oh, wow, this is insane. Well, one thing about it, we don't have to change the threes. Whoa, there we go. What's really frustrating when you do this and then you... Alright, so hopefully there's a lot of threes. Oh, there are a lot of threes. Good. Cool, 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 cool. Keep going, threes. Awesome. Okay, here we go. So these fours need to be recoded as twos. And again, I hope this is clear why this is going on. So you got your brackets filled out. Hopefully by the time you watch this, actually today is Kentucky's first round game. So I'm going to put this video up. If I ever get these fours changed to twos and ones changed to fives and stuff, put this video up and head somewhere and watch the game. Wow, this is incredibly boring. Sorry, guys. I should have done this beforehand. It's one thing I like about Excel in my office with my PC is this stuff just works quicker. It just doesn't work as fast with the Mac for some reason. My gosh, there's a lot of fours. Actually, I think there's only like 2,700 cases. So. Now let me. Oh, whoa! Back up here, Douglas. All right, and we'll get these changed to ones. We'll be set. All right. Something I want to let you know. I've another document that I will upload. I'm going to write this up. I don't like the way I wrote up the previous one. That was something I tried to write up on the fly, and it didn't. I don't think it worked well. So I've taken some time and actually written up this problem. It is something I'll upload on Blackboard probably later today. Well, I wish I could grab my coffee. Maybe we should play some Taylor Swift. What do you think? What about it, Nat? Guys, I just got your all's second attempt exams back. I haven't graded those yet. Okay, finally. Wow. Let's save this and go through all this stuff. All right, cool. I'm glad that's over. I'll tell you what. Let's do. Let's go ahead and bring up R, and let's get this. Entered. I think that's what I called it. Yeah. And you'll see the names of the data here are just question 1, question 2, question 3, and so on and so forth. So there's 23 questions. What you can do to always find the number of variables, you can do length of your data set, whatever you named your data, and it'll tell you how many variables you have. If you do the length of a variable, for example, Q01, it'll tell you the number of cases that you have. So Field gave this survey to 2,571 students, and we're going to analyze the data. Now he analyzed it as well in one of his books. I'm going to add some stuff that I think I want you to be aware of. So anyway, what the goal of this. Okay, well, let me back up a little bit. An important use of factor analysis is to develop surveys, questionnaires, and tests. And if you're trying to develop a survey or a questionnaire or a test that's kind of tapping into some underlying construct or some latent variable, something that isn't directly observable, reliability, validity, and principal component analysis is extremely helpful. So the primary goal of this video is to illustrate the process of developing a questionnaire, something that you would be able to use in research. Believe it or not, you just can't come up with something and say, well, here's 10 questions I'm going to ask my students. Let's see where it goes. If you're not going to use that in any statistical analysis and you're just trying to use it from a descriptive component, then everything's fine. But if you're trying to use it where you want to use these responses in future analysis or get your article published, you're going to have to get into PCA, reliability and validity analysis. Okay, guys, I guess we're actually ready to get this party started. I don't know. I guess the first thing I would do is I would be concerned with sample size. And I say concerned, I say that from a general sense. I don't necessarily think sample size is an issue here. Let me tell you why. There's 2 rules of thumb that I think you should put on your radar for sample size. And just go ahead. It's going to be one of those test questions you're going to run into. One rule of thumb says that you need at least 300 cases. Well, we have 2,571 cases, so we're set. The problem with that, in my estimation, is I think the number of cases is directly related to the number of variables. If I have 100,000 variables, then maybe 2,571 isn't enough. So it actually turns out that there is another rule of thumb, another rule. Oh my gosh, my dog is driving me insane. Hold on. When you want to go in and out. All right, my dog needs a doorman. Somebody just to stand at the door and let her in and out. Anyway, another rule of thumb is that that you have at least 15 cases In this case, it would be our students, per variable. So, guys, if you think about it, we have 23 variables, and I would like at least 15 cases per variable. So that says that I need at least 345 cases, and I have 2,571, so life is good on the sample size front. The next thing you always want to do is code and cleanse your data. We just did that. I always like to do that over in Excel. There's probably easier ways in R, but I just don't do that. Number 3, remember question number 3 had to be recoded, so we've already taken care of that. So cool. Now, next thing we'd want to do is look at a correlation matrix, and we should know how to do that. The problem is, think this through. We have a very, very, very large matrix here. Now, granted, the only thing you need to look at is the upper triangle or the lower triangle, and I'll show you a way to get that in just a second. Nevertheless, just by observation, this could be completely and totally overwhelming trying to go through here and determine what proportion or what percentage of the correlations are low. I like... Again, I pointed this out earlier. I like to round these things to 3 places. It just cleans it up a little bit, yeah. Plus, it makes it a little bit easier to read because we get our correlation matrix on 2 lines. So, but anyway, I think you drive yourself absolutely crazy if you try to examine these things and make a determination whether you have too many low correlation. So guys, remember we did the Bartlett's test, but first thing we have to do with Bartlett's test is access the library for psych. I've already installed the packages, so you probably have too, or at least I hope you have. So I do core test Bartlett with my data. Remember p-values above 0.05. What do you mean R was not square? How is R not square? Oh, my bad, guys. Well, let me back up a little bit. I need to use core test Bartlett with the correlation of our data. Okay, let me see something here. Core test. No, I don't, guys. I'm confusing myself. This is the one we need to record. But the core test. Yeah. This is it. Forget this stuff down here. I lost my mind temporarily there. So problems would be p-values above 0.05. So we have a p-value that's rounded to 0. So everything's good there. Where I'm getting confused is the determinant, the correlation. And remember, this needs to be greater than 0.0001. I think I only said 3 ones, but I should have said 4 ones. And 0.0005 is clearly higher. So we have no problems with too many high or low correlations. So life is really, really good. So let's go for it. So the first thing I want to do here is I want to run my first principal component analysis, and I want my n factors to be the number of variables, which are 23. And the first time I want to get the boring factor loadings or the PCA loadings and do none. What's going on here? Oh, shoot. You guys ever just sit there and like scream at me like, Darbro, what are you doing? All right, so we look at PCA1, and it's going to be good to go back over this. Remember, these are your PCA loadings, and before any rotation, they're not at all interesting to us. Remember, these are your commonalities. These are your uniqueness factors. All these are 0. This is negative 2.2 times 10 to the negative 16. But what is of extreme importance to us are the eigen vectors. I'm sorry, the eigenvalues, and they are housed under SS loadings. So I'm looking at this, and I'm kind of old school on this. There's a lot of new stuff out there that's kind of taken over the market. But I'm kind of a firm believer that unless my scree plot shows otherwise, I retain the components that have eigenvalues above 1. Now, I've got something going on here. That 0.99 for that fifth component is something that's interesting to me, and I'm probably going to want to examine that if there's anything going on with my scree plot that doesn't give me a clear indication of the number of components. This fit based off the diagonal values. This is really interesting to us once we perform the rotation. But as it stands right now, that's not interesting at all. So I don't know. It kind of looks like to me that I'm leaning between 4 and 5 factors. So I'm going to do my plot, my scree plot. And I want to do $1 and what do I use there? No, values, yeah. Equals B. Okay. Now I get my plot here, and I'm trying to just really determine where the point of inflection is. So I come down here. The first factor is really overwhelming. You can tell the kind of the verticalness of that bar and how long it is, and you can see that the reason that has such length is because my first eigenvalue is about 5 times higher than my next one. So, I've still got vertical. That's kind of throwing me off a little bit. So. But then I come down, and then this horizontal component, clearly I'm thinking horizontal, 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 and right here is where it starts to take a vertical move. So I'm looking at a 1, 2, 3, 4 component model here. And again, there may be an argument for that fifth one, but I think this is more of the horizontal inflection than it is the vertical. So gang, I'm feeling more and more cool about a 4-factor model. All right, so that's what we want to do. So let's run that again. So I'm going to call my next PCA2, and okay, got some stuff going on outside. One of the bad things about teaching at home is there's so daggone much stuff going on. Actually, my next door neighbor just passed away Saturday, so there's her family's been in and out. She was, I think she was 88. She's a cool neighbor, so we're going to miss her. Okay, gang, you can't do a rotation until we install the library or access the library for GPA rotation. I've already installed that, so you may need to as well. And now we get PCA2, and let's see what happens. Now, gang, the PCA loadings now start to take on some meaning. So it looks like question number 1 has loaded on component 1. It looks like question 2 is loaded on component 2. It looks like question 3 has loaded on component 1, and so on and so forth. The H2, when I come down, let's just pick one, talk about it. This point 74, this tells me that question 8 is highly dependent on other questions here. So 74% of the variance in question 8 is shared with other questions. Only 26% of the variance in question 8 is unique. So again, the way you get that is just subtract your commonality from 1 to get your uniqueness. So I don't know. That's stuff that you can run around and talk about and make people think that you're really smart. Again, what I like down here is the cumulative variance with these components. We're looking at about 50%. Let me go back up and look at what it would have been if we retained the 5th one. So it went up to 55%. I tell you, I'm sticking with the scree plot. I'm going to go. I'm feeling kind of jiggy, whatever jiggy is. I don't know. That's the first time in my life I've ever used that word. I'm feeling pretty jiggy of the 4-factor model. So, guys, next thing I'd want to do is I'd examine the residuals. So let's do that. So I'm just going to store these very creatively as residuals because I'm clever that way. Guys, I got to tell you, I'm in a great mood today. Got Kentucky coming on. I'm not going to be in such a great mood though if they lose. Oh shoot! What I put there? Loading sim. And if this kind of stuff turns you on, you can look at your residuals. I think they absolutely drive you insane because there's so much going on. And again, if I ask you in a test question, what's that 0.56 tell you? That's just the difference between the residual from our original data, retaining all the components, to the residuals retaining 4 components. So that's a little high. That's actually a little problematic to me. But really, though, what we're going to do, we're going to be more worried about the upper triangle than we are actually the values on the diagonal. Not as much how the correlation changed with itself, because that started out a perfect 1. So, guys, I want to put these as a matrix because I want to do some stuff with them. So I'm going to restore the residuals as matrix. And I want my residuals. Now I want to come in with and just get the upper triangle. I think that's the way that... let's see, that'll be a miracle if this works. Upper... I may have to stop and go look that up. No. Oh, wow, cool. Now, I want to identify my large residuals. And guys, the way we identify large residuals is, and again, think of it, let me back up a little bit. Why do we do the upper triangle? Well, what that'll do, it'll give me everything above the diagonal, because if you think about it, everything below the diagonal is just symmetric with everything above the diagonal. So I just need to look at those. And what I ultimately want to do is I want to add these things up and look at some means and look at histograms. And I don't want my residuals counted twice. So I just want to focus on the upper triangle of the matrix so I can just count the residuals one time when I get some of this descriptive statistics stuff. So what I'd like to do, I don't really care about sign, a 0.95 correlation and a negative 0.95 correlation. Extremely high, so I'm not really into that. And it turns out that the threshold on these things is 0.05. So absolute residuals that are higher than 0.05 can rise concern. Now we're just naturally going to have some of those, and I can go through here and eyeball, like there's one, and there's one, and there's one. But how many do we have? So we can store the number in as the large residuals, or not the number, but we can store all those in as large residuals. Now, the next thing I'd like to do is I'd like to find the percentage of our total residuals that are large residuals. So I might just call this percent, because again, I'm creative that way. And what I'd like to do is get the sum of my large residuals. So how many are there divided by the total residuals. And I can do that this way. What did I... Oh, okay, I see what I did. I didn't spell correctly. as much as I deal with R, it still kind of blows my mind sometimes when I get those errors. So guys, what we get there is we get a percentage of our large residuals is 36%, or 35.97%. But the threshold here is 50%. You don't want 50% or more of your residuals to be higher than 0.05. Now, tattoo this one to the brain. What happens if what if we'd run this and it turned out to be 60%? Then what you would probably want to do is you would want to retain more factors. So that would be a situation where I would want to go back up, rerun my principal component analysis with 5 factors, and redo everything and see what it takes to get this percentage below 50%. So, gang, what I can now do is I can look at a picture of my residuals. And you can see down here that 0.05 again is kind of the threshold. You can see that most of them are below 0.05. I'm going to copy and paste this into the write-up, so you'll get that. Next thing we'd want to look at is want to look at the mean of the residuals, and another threshold for problems would be if the mean of the residuals was above 0.08. Now, we don't actually find the mean of the residuals. What we find is called the root mean square residuals. So this is equivalent to the mean of the residuals, okay? Because you got a bunch of residuals that are negative and a bunch that are positive, so we need to address that. So the way I would do this is to find the mean. I would just do the square root of the mean of the residuals squared, just as it says. So our mean of the residuals here is 0.056, or I'm sorry, 0.055, which is below the threshold of 0.08. So life is good. Oh, wow. Okay, I didn't even type that. It just popped up. Okay, so gang, I'm feeling really good about this decision to go with 4 components. So I'm kind of ready to make things happen with the reporting this, and if I wanted to do something with the factor scores, I would feel very comfortable doing that. Now, let's review. All right, I feel good about 4 factors for 4 reasons. Well, that was cool that the number of factors turned out the reason I feel good about it. But number 1, I'm happy with greater than 1 and the scree plot. These both agreed, so I'm cool with that. The second thing, we have 15 times 23 is greater than, our number of cases. So 20, I forget how many cases we had. Let's just say our number of cases, individuals, is greater than 15 times 23. So 15 is just the multiplier, the constant. So I'm happy with the sample size. The third thing, we checked our residuals. And found out a couple things. Histogram was bell-shaped. And it appears it came from a normal distribution. Our mean was below 0.08 and less than 50% of our residuals emerged less than 0.05. Okay? So I'm feeling good about this stuff. And finally, the fourth reason I'm feeling good about the four-factor model is our model fit from the output is greater than 0.90. Now, guys, I don't think I really focused on that, so let's go back up here. The fit based on the off the diagonal values, 0.96. So I like for this to be above 0.95, but it's essential that that's above 0.90. If it's not above 0.90, then you would need to go back and strongly consider pulling out more factors and going with it. Okay. Now, our orthogonal rotation is really cool, so to speak. Now, but I want to examine this further. So I called this PCA2. So I want to go into this and look at things a little more closely. Now, what I would like to do is I'd like to come into my PCA loadings, and I don't want all these small, like negative 0.04. The only thing I want to show on question 20 is this one, because this is the PCA loading that tells me the question 20 loaded on component number 1. So I don't want this garbage right here. I don't want 0.07. I don't want 0.14. So if you remember from the previous video, we can do the print psych. And we can do our PCA2. And we can set our cut. I'm going to set it a little bit higher here at 0.4 because our model really turned out pretty cool. So here's what I get. Now, what I like is when I look down through here, I don't want a lot of replication. So I'm looking at components 1, 2, and 3. And when I look down through here, the only thing that I have that loads on 2 components is question number 12. So I might want to come back over here and examine question number 12 and see what's going on with that. So question number 12, people try to tell you that R makes statistics easier to understand, but it doesn't. And I can see where that's kind of a vague question. It has loaded on 2 components. To be quite honest with you, I would probably consider eliminating that question if I really wanted to strengthen up the reliability analysis of the survey. But I'm not going to go with that. I'm going to just come in and I'm going to write these down. So factor 1, let's go with that. So that's under RC1. So it looks like, I'm going to write this down. So we have questions 20, 21, 3, 12, 4, 16, 1, and 5 that load on component 1. Now, what do those questions have in common? So I got to go back and I don't even think I'm going to use that, so I'm going to get rid of that. I got to go back and think about what these things actually have in common. So question 20, I can't sleep for the thought of eigenvectors. Okay. I wake up under my duvet thinking I'm trapped with a normal distribution. Okay. Question number 3, standard deviations. Starting to see a pattern. Number 12, that's the one I think is a little vague. I'd probably consider getting rid of that. This is talking about a Pearson correlation, number 4. 16 talks about central tendency. Notice that every one of these questions has terminology dealing with statistics. Statistical terminology. So guys, I'm going to call factor number 1 my statistics factor. Let's come back in and look at factor number 2. Factor number 2 over here deals with questions 9, 22, 23, 2, and 19. So let's see what those questions have in common. So question number 9 says, my friends are better at statistics than me. 22 is, my friends are better at R than me. 23, if I am good at statistics, people will think I'm a nerd. Okay. My friends, and number 19, everybody. So this is a kind of I'm going to call this a peer, a friend, if you will, a peer evaluation. How the subjects think about kind of peer perception. Let's go on through the next one because this turns out to be kind of the hardest part. Let's look at component number 3. So I'm going to write these down. So 6, 18, 13, 7, 14, 10, and 15. And again, we're with this question 12, even though it loaded above 0.4, we're going to have it on component 1. So component number 3 here, let's go over here and look at these questions and see if we can determine something that's common. Number 6, I have a little experience with computers. Number 18, R always crashes, so that's a computer. 13, computers. 7, computers. I think you see where we're headed here. 14, computers. And 10, computers. And 15, computers. Guys, I have no doubt that factor number 3 deals with computers. So I'm going to call that a fear of computers. So the only thing we're lacking now is the short one. So that's question 8, 17, and 11. So question 8, mathematics. Did I say 8, 17, 11? Equation, mathematics, 11, mathematics. So guys, that to me is the mathematics component. So these underlying constructs that we've kind of unraveled or we've detected, it looks like to me are fear of computers, fear of statistics, fear of mathematics, and a kind of a peer evaluation component. Okay. Now, what can we conclude once we've got this big old fancy schmancy these factors that notice that emerged so nicely and very mutually exclusive, if you will, on these components? I don't really know what we can conclude. Maybe maybe there's nothing going on. Maybe it failed to measure any sort of R anxiety, but did find some interesting stuff like fear of computers and fear of math and stuff like that. Or it could be very likely that the 4 constructs that we have tapped into here, again, fear of computers, fear of statistics, what people think of us, and so on and so forth, are truly constructs or subcomponents of the anxiety of using R. Well, guys, that's the one for bigger, better things. That's something that you guys will have to figure out. Okay. Now, think about what we got going on here. We've got the components turned out to be fear of math, fear of stats, fear of computers, and peer evaluation. Now, is it reasonable to think that these things may be correlated? Is it reasonable to think that fear of math is independent of fear of stats, that's independent of fear of computers? I would say there's some sort of interdependency going on here. Now, one assumption of orthogonal rotation is independence, or I should say uncorrelated components. And it looks to me that we can reasonably, qualitatively, if you will, say that there probably is a relationship between fear of math, fear of stats, fear of computers, and fear of evaluation, especially the first three. I don't have a fear of math. I don't have a fear of stats. I don't have a fear of computers. Sometimes I care about what people think of me, but it just depends on who the people are. So I don't know. I think if you ask most people this question, you may reasonably conclude that there is some sort of relationship there. So we would want to examine this with the orthogonal. With an oblique rotation. So I'm going to call this oblique, and I'm going to run the principal. And really, all I want to do here is I want to run the same thing. And I tell you very honestly here, what you hope, just because. Okay, I forgot how to do this. Oblique, is that it? Oblimin? Yeah, okay. What I always hope is when I run these that I get the factor loadings that they're very, very similar to what I got from the orthogonal. Because orthogonal is just, it's a rotation that you see presented more often. It's something that's more understood, it seems to be. So that's kind of what I hope for here. Now, the first thing I notice is 0.96 is the same. That's encouraging. The next thing I want to look at is the component correlation. So we can see that component 4 and component 1 are highly correlated at 0.44. In fact, component 1 and component 36, component 3 are relatively highly correlated too at 0.36. Component 2 and component 4 are not highly correlated at negative 0.1. Doesn't matter. So this kind of raises the eyebrow and makes me think that the oblique rotation may give me different results than the other. So let me go back up. I didn't write down component 4 was what, 8, 17, and 11. So guys, all I did, I'm not doing anything fancy here. Only thing I did is just on a sheet of paper over here, I wrote for component 1, for example, that I have question 20, 21, 3, 12, and so on and so forth. I did that for all the factors, or all the components. Now, it's going to be easier for me to read here if I do the print psych. And I want to do, what did I call this? PCA oblique. And I want to keep my cut consistent at 0.4. And sort, that's kind of a handy tool to do that. Okay, now when I come back up here, I look at my component 1. I see 6 and 18 and 7 and 13 and 10 and 14 and 12. 12 actually loaded on component. On a different component, this one, and so the oblique gave me a little difference in question 12. Question, see, 8, 11, 17 turned out to be the same. 20, 21, 3, 4, everything but question 12. I tell you what, I'm willing to throw in the towel here. Question 19, that's interesting. Question 19 didn't load on anything. Where did question 19 load before? It loaded on factor 2. So maybe I set my set points too low. Let's go in here and go back up and let's set the cuts at 0.3. I don't know. Question 19 therefore loads on factor 2. Exactly where it loaded for the orthogonal rotation. I don't know. I'm tempted to probably go ahead. Let me explain something in your in this this orthogonal, I'm sorry, this oblique rotation. You end up with two matrices. One thing you end up with is your pattern matrix. And what this thing does is it contains the factor loadings, much like the orthogonal rotation. In fact, if you would end up with a situation up here where all of these correlations were zero between the components, the correlations between the components were all zero, so there was complete independence. Your pattern matrix would be, and let me show you, this is what you get. You get your pattern matrix here, okay? So it's given in your output, and it's going to be really close to your orthogonal rotation if your factors aren't correlated, which means they're independent. Your structure matrix is different, and this accounts for the lack of independence. So it looks up here and it's like, wait a minute now. This component number 1 and component number 4 are moderately correlated. So let's control for that. Let's control for the independence between between the factor, between the components. So let's go ahead and do that. It turns out it's easy to do. So we do loadings. These things actually are matrices, so we have to do this craziness. And then we do phi. All right. So okay. Well, I'll tell you what, this would take some examination. I don't know if we can do the print psych on this or not. Let's try that. Let's do a cut. I don't know if this is going to work or not. No, it's not going to. Yeah, this is a matrix. Well, guys, you just have to crunch through this, and I don't want this this video to go on forever. So, yeah, I don't know. What you'd have to do is you just get. Let's just choose one of them. For example, question number 20. It loaded on component 3, right? And question number 7, just a random selection. It loaded on factor 1. Okay. So you know what? I would go through and probably take a look at where each of these fell and compare it to the for example, question number 1 would load on component 3. Question number 2 would load on component 2. And I would go through and just maybe do a kind of a chi-square goodness of fit test and see if the loadings were actually different. I don't see anything that jumps off the page here, but again, this would be something I'd need to get in a quiet corner and sit down and actually run through each of these and see where they where the question is loaded for the orthogonal rotation, and see how they loaded on this structure matrix. So, guys, I'm going to leave that for bigger, better stuff. But if you get into this for your master's thesis, which is a good chance you will, then that's something you ought to think about. Guys, give me 2 minutes. I need to check on something. All right, gang. Sorry about that. Okay, let's get ready to wrap this stuff up. It looks like to me I am extremely happy with this four-factor model. I am, if I wanted to use these factors in something, I would feel comfortable doing that. Guys, I'm assuming that we have a viable solution. I'm okay with, again, using the orthogonal rotation results if I was going to publish something. Now, the next thing I want to look at are the factor scores. And guys, let me make a something important here that I want to point out to you about creating the factor scores. These things aren't like factor loadings. Factor loadings are the things that we get back here. And notice the factor loadings and factor scores, sometimes people confuse those and they shouldn't. This just gives mostly a correlation of question 6 with component 1. And notice the big difference is for PCA loadings, factor loadings, the rows are the questions, the variables. But when we get factor scores, we're still going to have a similar look across the top. We're going to have our components, but the rows are going to be the subjects of the study. So each student, all 2,751, I think it was, will have a factor score on each of the factors. So that's a huge difference there. So guys, to get the factor scores, it's super easy to do. And what I'd like to do is not only get the scores, I'd like to be able to save them in a new data frame. So I'm going to go cbind, which is going to bind something new with something old. So I want to bind the something old, my existing data set, with the new scores from the PCA2. Now guys, remember, I've examined the oblique rotation, so I'm happy with this this PCA2 back here. I'm happy with this orthogonal rotation. I call that PCA2. So that's the reason that I'm putting it in there, okay? Now, what I can see now is I have new data. And it's a little strange because it's a huge data set. When you have this many people who have participated in the 2,571. But the cool thing now is I have a variable called RC2. So if I wanted to find the mean of RC2, I cannot do that. Okay, why not? Okay. Okay, there we go. So I just had to attach the new data set where I bound the new stuff in there. So we can see that the mean of the factor scores for RC2 are 0. And I'll just go ahead and show you something so you'll know this in the future. 0. Gee, I wonder what this one will be. You got it. And same thing for the fourth one. All right. So gang, we could use those now instead of, let's say that we were wanting to use these questions in some sort of multiple regression, but we're concerned with high correlations and multicollinearity. And secondly, imagine how large a model you would have if you have 23 predictors. Well, in this 4-component model, we retained about 50% of the variation in the underlying constructs that the 23 items actually explains. So you know, we could use the components. I'm sorry, the factor scores instead and the great thing about the factor scores is they're already centered, which is always kind of cool. All right, gang, I'm done. I'm ready to go watch some college basketball. Here in well, Kentucky doesn't play for another 12 hours or 11 hours, so it's going to be a while, but give me a chance to get some work done. So next thing, once you finish this video, what I would encourage you to do is to take a look at the write-up, which will be under Blackboard. It'll be under the same week, I think 10. So guys, have a good one. Take care. Bye.